Next important idea, I guess, with coordinate geometry is when we look at the slope or the gradient. Possibly the first way we thought of it was vertical rise over horizontal run. So let's just draw a line in. There's a line which I've called L. There's a particular point, or 2 points on that line, 5, 5 and 2, 1. That's when we found it convenient to use the formula, y2 minus y1 over x2 minus x1. So again, similar to when we found the distance, it would be easy enough to draw a right angled triangle there with that slope part being the hypotenuse, and then the vertical rise is the difference in the y values, and the horizontal run, the difference in the x values. In this case, it is important the order we put them in. It does need to be the same, because positive or negative in this case has some meaning. If it's a positive slope, we know the line's going up or increasing. If it's a negative slope, we know it's going down or decreasing. So we do have to make sure we do it in the same order. So how did I do mine? I chose the point 5, 5 to go first. So 5 minus 1 on top, 5 minus 2 on the bottom, giving us a slope of 4/3. There is a third way of finding slope, which people often forget about. So I'll draw another line in to illustrate it. And that's when we know the angle the line makes with the x-axis. And so the third way is the slope is the tan of that angle. The angle, which is known as the angle of inclination, and it's always measured to the positive side. So it needs to be to the positive side, because that way, like if you look at the red line, it's going up. It forms an acute angle, and the tan of an acute angle will be positive, and we want a positive slope. As opposed to the blue line, which is going down, but now that angle is obtuse, and the tan of an obtuse angle will give you a negative number. So that's why we need to go to the positive side, so we make sure we get the sign correct. So it would be possible to work out that slope if I know that's 120 degrees, and it's simply the tan of 120, which is minus root 3. I could also work out the red one, because we worked out the slope was 4/3. So I could work out the angle. Slope is the tan, so tan alpha is 4/3, approximately 53 degrees would be that angle. Now, two lines are parallel if they have the same slope, and no, I have not spelt if incorrectly. Okay, that is the correct spelling of if. Right? No, I see some of you are looking confused. If and only if, correct. So when you see if spelt that way with 2 F's, it actually means if and only if. It basically means, I suppose the simplest way of explaining it is you can read the idea backwards. It works backwards and forwards. Not all things do. So two lines are parallel if they have the same slope, but we could read it the other way around, where we can say, hey, if they've got the same slope, then we know they're parallel. So we can conclude either way. So slope 1 would equal slope 2, for instance. As opposed to perpendicular, that's when they're the negative inverse of each other. I suppose the simplest way of explaining negative inverse, multiply together to give negative 1. So we've got 4 points, and we're going to find A such that, because you'll notice in the fourth point we don't know what the x value is, but we want it such that AB is parallel to CD. So if they've told us that, we can conclude, that means their slopes are going to be equal. So if I find the slope of AB, I get 2. The slope of CD would be 2 on A minus 3. But we know if they're parallel, then the slopes are equal. And by the way, when you're setting your working out, you should be making that sort of statement in a solution like this. I mean, why did you make these things equal? There must have been a reason for it, so you explain yourself. Okay, so you're saying, well, I know that if they're parallel, then these two slopes will be equal, so therefore I can make this statement, the 2 is equal to 2 on A minus 3, giving us A is 4. Well, what about if they were perpendicular? Well, now I know, well, if they're parallel, I was going to say again, if they're perpendicular, then their slopes would multiply together to give negative 1. So this is the one I'm solving now, and we get A is negative 1. classic question. You've probably seen similar ones yourself, where they give you 3 points on the diagram and they want you to work out the fourth point if it is, in this case, a parallelogram. So the naming of the shape's very important. So there's A, B and C, but they've named the shape A, B, C, D, and we always name shapes in cyclic order. So therefore D must be, well, let's draw in A, B, B, C. D must be down there somewhere. Now I'm going to use the fact that everything's parallel in a parallelogram. So similar, I guess, to what you were just saying. This is probably the easiest way of working out the coordinates. You could waste a lot of time with this question. You could find the equation of AD, then find the equation of CD, then solve them simultaneously, and you'd come up with D. And it would work, but it would take a lot longer than just using the idea of parallel. And what we mean here is, well, I know to go from B to A, if you like, I go across 3 and down 5. Therefore, I must do exactly the same thing from get to C to D. So that tells me if I've gone 3 across, I must add 3 to the x value of C. And I've gone 5 down, so I'll take away 5 from the y coordinate of C, and we end up with the point 0, negative 10.
Can you do like a midpoint formula?
Yes, that would possibly be another way of doing it. You could find the midpoint of AC, and because we know the diagonals in a parallelogram bisect each other, it would also be the same midpoint as BD, and that would allow you to find D as well. And I guess that's the beautiful interaction between Cartesian geometry and Euclidean geometry. We can use, all our theorems to help us solve problems. Now, if you want to prove 3 points are collinear, so collinear together on the same line, probably I think the easiest way of doing it is, well, we just pick 2 of the points, so I've said A and B, and we'll find that slope. Then we'll just pick another pair and find that slope. Now, if they're equal to each other, we know they're parallel. However, they have a common point. So because they're a common point, they can't be on different lines, therefore they've got to be on the same line. So I think that's probably the quickest way of showing 3 points are collinear. So we'll just work on some more coordinates. Oh, an asterisk on number 24. Oh, wonder what that one is. Okay.